I was contacted by icstation.com and they offered me a few things off their list of new products. Now actually I only said yes to this one, so this is a kit which has got it's one of these ones that's got coloured LEDs and you build like a little tree structure out of them, so like a little LED sculpture kind of thing. So I'll build that at some point. They've also given me a couple of other things. There's another kit that involves LEDs. It looks quite nice. I don't really know what it is, but there's a couple of circuit boards in there. Now I might have to put that in another video because that looks like a whole big construction thing on its own, so let me put that to one side. But I thought today I would look at these two things. So this looks like a boost converter, and I can very quickly get that up and running and show that working. So let's do that first. You can see quite a few of these type of things on eBay and the Chinese websites that have the same philosophy. So a small circuit board, typically with the inputs and outputs on opposite sides of the board, and you've got a standard chip, which some of these are boost converters, some of them are buck converters. Pretty sure this is a boost converter, but we'll see shortly. So you get a standard chip and then a variable resistor so that you can adjust the output voltage, and these are very cheap and very efficient and really a rather good alternative to the kind of more conventional sort of linear regulator where you're kind of converting waste energy into heat. So these are kind of switching mode regulators that by switching the output on and off very fast give a very efficient way of switching between different voltage levels. So I'm going to solder some bits of wire onto here so I can more easily connect stuff on, and then we'll put some volts in on this side and measure this side and see how this goes. So I've put some wires onto this unit now so we can put it through its paces. So I've got a meter here that's looking at my power supply. I'll just put these wires on the input side. So we've got 5 volts going into the input side, and if we put the crop clips from the other meter on the output, so we can see that reading just a little under 5 volts, so it's obviously turned right down now. So we'll turn the screw here and try and increase the voltage. Let's go the other way. There's not much happening. Not sure which way to turn this to. Not a lot happening there. I took this to be a boost converter, but I'm wondering now whether it might be a buck or a step down. Let me just turn the screw out to the left a bit more. Oh, here we go. So that's suddenly jumped up, didn't it? So it's reading 15. Right, so it's definitely a boost converter. It's reading about 10 volts at the moment. Let's wind it right up, see how far it goes. I think it's meant to be about 25. There, I think that's as far as it's going to go. Oh, 28, nearly 29 volts. Okay. So I don't know if I might have to dig out a load resistor. This is meant to be able to provide up to 2 amps. I should put a load on it and make sure that it's doing something. But as you can see, when it's very jerky in operation. So 1 minute it's reading 4 volts and then it jumps up really quite fast to 10. And a couple of turns takes you to nearly 30 volts. Alright, let me find a load resistor. We can put that on. I found a resistor that I can try. So this is 22 ohms, 3 watts. So I need to keep the power within that limit. So I've just done a couple of calculations which I can share with you. So I've got the power 3 watts, resistance 22 ohms. So using P equals I squared R, I can work out what the maximum current is, I. So I work that out to be 0.37 amps. So with the resistors I've got, I'm not going to be able to go up to the full 2 amps, but just to give some kind of demonstration. And then from that I can work out the voltage that I should set it to. So the voltage in this case, the 0.37 that I just worked out times the 22 ohms gives me 8 volts. So as long as I keep the voltage down below 8 volts, I should be alright. I should be alright to use this particular resistor without burning it up. So let me turn this down to 8 volts. There you go, 7.9. And to bend these slightly, I think, to get everything in. Use my croc clips to hold everything together. Right. Oh, that's interesting. If I put that load on, it's obviously the voltage is going down to 0 practically. I mean, less than 1 volt. So that 22 ohms is really shorting the thing out. Oh, I can see my power supply is going into current limit. Hang on, let me change that. more like it. Right, so that's under load now. I can see my bench power supply is pulling, what's that, 700 milliamps, and we've still got the 7.9 volts on the output. That is extremely hot now. Okay, so that's providing at least 3 watts, well, around 3 watts, isn't it? It's very hot. There's nothing very hot on the board here, so that's encouraging. Yeah, so I mean, that's going to be useful in some setup that I've got, I'm sure, to boost up a voltage, anything up to 28 volts it seems. So that's a nice little addition to my toolbox. So looking at this kit, which is the thing that I asked IC Station to send me, so you can see the product number there in case you want one of these yourself. So let's have a look what's in here. So we have the base PCB here, double-sided through hole. Piece of perspex, which I imagine is the top plate. I'm not sure, I haven't really looked at any assembly instructions for this yet. So we've got a bag of leads. I don't know what colour those are at the moment. There did seem to be several choices of kit, and they've given us some wire. What else? Some screws and nuts, assembly hardware, a micro USB connector, a switch, and a chip. Let's have a look what this chip is. So 15F104. So I think that's a PIC chip. So its legs looking a bit crazy, but so that will already be programmed with the light pattern, I would guess. Let's have a look at these LEDs. We've got a battery here. I'm not sure if you can see that, but that's blue. So I'm not a huge fan of blue LEDs. They're a little bit passé. So I might dig out some other ones, maybe some nice red ones, and put those in instead. Now obviously the chip goes in the centre. There's one row of, I'm not sure how the LEDs are arranged. Many of these things you actually construct. I mean, I've never built them before, but I've seen other people build these, and I think the idea is that you kind of, you know, you bend a leg up and you solder the legs together and you build a structure using the wires as the support. But I might just go and take a peek at the IC Station website and see if there are any clues on how to build this. Alright, so I was just looking at the LEDs that I've got, and the box of LEDs I was looking for doesn't have as many as I really wanted, so I'm going to go ahead and use these blue ones. So basically we've got 4 layers of 8 LEDs, and the way that this seems to work is on this PCB there's there are 4 that are connected to the board directly and then there are 3 more layers that are built on top using the legs as structural elements. So above that first layer they say to bend one of the legs out, and then so then you've got one leg going down which you've soldered to the lead below, and then the one going out at a right angle is a kind of structural element that joins to the next one around the chain. So I'll construct that bit by bit and try and show how that's done. Looking at the board, so there's obviously a place for the chip there, so I'm going to have to bend those legs back into good order and solder in the chip. And it seems that the switch and the micro USB go underneath. So I think where I'm going to start is I'm just going to solder in the chip and those 2 elements on the bottom. Maybe I'll put the first row of LEDs in there as well, which will allow me to put power on and make sure that at least the first row of LEDs is going to light up. So that will be a good way to start, I think. These screws seem to be legs, so the idea is you put them down through the board and tighten the bolt on the back, and so it's like a standoff. And this thing here, I thought this might be the top of the structure, but I think reading the instructions on the website, it seems that you kind of place the LEDs in here as a template to make the structure, to make the ring, and you can bend the legs and do the soldering, and then you pull them out and you've got the correct spacing. So that's something I'll demonstrate as well. Have I missed anything? Ah yes, so the wire. The reason there's some wire here is that basically when you've built the tower with the 3 extra layers on top, the negative of the LEDs has to be wired back to the board. So if you look underneath, there are these through holes here that are labelled COM2, COM3, COM4. So that's where the wires go into for the 2, 3, 4 layers. So what seems to be happening is that each layer has its own independent switching, so the lighting effects do different things at different times with the different layers. So it'd be quite interesting to see what this does. So first of all I'm going to put the chip and the other elements in there, and then we'll start doing the LEDs. So I've put the 3 screws in as legs now, and added the other components of the chip, which is through hole, so soldered underneath. The switch, so you bend the legs and drop them through the holes. I soldered on top, but the solder goes through the plated through holes. That gives a nice, good, strong physical connection there. And then finally the micro USB socket, which it's a little bit tricky to solder those 2 connections. There's basically the outer 2 connections are the ones that need to be soldered because they're the power pins. So what I did is I just tinned the tracks on the board a little bit and then held it as precisely as I could in place, and just put the soldering iron on and let the solder flow, and that seems to be joined pretty well. And then you'll see there are these flaps around the side, and you solder those just to give it a bit more sort of physical strength. So I'll go ahead now and put in that first circle of LEDs, and then we could do a power up and see what the just one row of LEDs will do for us. Just a quick test. I plugged in a power bank into the micro USB here, and if we just put one of the LEDs in, so they say longer pin to the outside, so that's normally the positive on LEDs, so there's just friction holding that in, and if I switch it on, you can see that the LED is doing something, so it's kind of glowing. And so we could put in a few more LEDs around the outside. One more. Right. So they're kind of lighting in pairs. You see it's going around in a circle now. So so they give you a full set of LEDs and a couple of spares, which is quite nice, because sometimes you can break one during construction, so that's a good idea to have some spares. So what I'm going to do is arrange these in this little jig that they provide, and then get them all soldered in with the correct spacing, and then we can look at making the next layer up. There we are. There we are. So I put some solder on that first row of pins. Actually, this bit of perspex as a former is a good idea, because otherwise it would be really difficult to get all of these LEDs aligned. So there we go. So now we're going to build the next row. I think that probably the easiest thing is to put the LEDs in this former and solder all the negative legs together, so we have a circle, and then the outer legs get soldered to the outer legs of the existing ones here. Of course, you have to somehow bend that outside pin, the anode needs to kind of go round the, if I can show this, needs to go round the outside of the LED below, so because it's going to have to mate with that outer piece of wire there. So it looks a little bit tricky, but let's have a go at that. So this is what I'm thinking. Put them all into the former like this. You see, I've bent all of the cathodes out at 90 degrees, and so where the lines cross there, I'm going to put a little blob of solder, and I should end up with a ring that's got all of the cathodes connected together, which means that all of the anodes can reach down and be connected to the LEDs below. Alright, so I've soldered all those cathodes together now, and you see I've also bent out the legs a little bit, then bent it back so they can kind of curve over the LEDs below, and that's what the final thing looks like. So I'll now, I mean, these things seem to take more than a pair of hands, but so I was finding it difficult to get those solder joints in. But what I'm going to do now is go around and solder all of these to the outer leg of the one below. So that's the second layer now soldered on. Mechanically that's quite difficult to do. I found if I put a blob of solder on the tip of the soldering iron, then I could kind of hold it in place with one finger while I got enough solder on there to hold it in place. And I did the opposite sides to give it some strength, and it gets easier as you get more wires connected. As you see, I've also added this wire here, so the white wire's wired into COM2, so that needs to go onto the negative side. But if we plug this in now, see what this is doing. So that first layer is still working, so that's encouraging anyway. And if I touch this wire on the negative side, we should see if the top layer is working also. Yeah, and that looks like all the LEDs are lighting. So next is, well, obviously put that wire on, run another wire down to COM3, and then we'll repeat. So put another 8 LEDs in the former and make another ring for number 3. Just to show you, I don't often get this thing out, but this kind of gripper thing is actually quite useful for assembling these LEDs, because you need an extra hand with this really. So, because to get these in, you have to kind of put it in the hole and cross that wire with the next lead along, so that you can solder that in place. And it's a little bit fiddly getting the solder in. There you are. So there's the third layer in place now, and I brought up the white wire here from COM3. I've put another wire in for COM4 as well, and I've already, while I was working with the little plastic jig, I thought I'd do another ring, the final ring. So let's plug that one in. There we go, that third row is all the LEDs are working, so that seems to be complete. So there's just one more layer to add now. So there we are, the last ring of LEDs is in place now, everything's soldered on, and see the final white wire there going from the cathodes on the top ring down to that COM4 it is. So there we go. Now if you switch this on and off again, it actually starts doing a different sequence, so it's got some kind of fading patterns. See, that's fading in very slowly, fading out. And changing the LEDs. Yes, it's got several different things that it can do. This one is like rotating pairs of LEDs. But anyway, so there we go. That's how to build one of these. I've never built one of those before. Also, little sort of fun lighting effect that you can have in the house. And thanks to icstation.com for giving that to me free of charge so I could build it.